Good morning, everyone. Before we start today's session, please feel free to do event check-in. This will give you access to additional resources and information about events that we run on Reactor, which are around similar topics to today's session. I will share the event check-in link with the event ID in the Q&A section shortly. Thank you all once again for joining us today. My name is Rashmita and I'm the event planner for Microsoft Reactor Bengaluru, India. This session will run over the next 120 minutes, including Q&A. The session is being recorded and will be uploaded to our Reactor YouTube channel. I will share the link to our YouTube channel in the chat section soon. Quick word on our code of conduct. We display this at all Microsoft Reactor events that we run, and it's just a reminder to be aware of others. Key thing to take out here is to be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat will be open throughout, and we do encourage you all to participate. I would now like to welcome Shivam, our speaker for today's session. Shivam is an author, cloud architect, speaker, and a co-founder at Scalable. Being passionate about ever-evolving technology, he works on Azure, GCP, machine learning, and blockchain. He is also a Microsoft certified trainer. But for now, I will hand over to Shivam to begin the session. Over to you, Shivam.
Thank you. I'll quickly share my screen. Okay, so everyone, good morning, and thanks for joining in for the session. And today we have the session on real-time analytics with Azure Synapse Analytics and Cosmos DB. So if you have joined me for the previous sessions, then we were talking about Databricks last time. And before that, we talked about another Synapse session itself. And today we will go in more depth in the real-time analytics world. So how do you do real-time analytics? And I have the agenda with me over here. And if you have joined me for the previous sessions, then you also remember that we take a case study based approach. So we will understand one customer scenario today. And based on the customer scenario, we will basically understand the services. We will understand what is Synapse, what is Cosmos DB, how do we do advanced analytics over there, what is HTAP, hybrid transactional analytical systems as such, what is OLTP, what is OLAP, what is the role of a data engineer, what is the role of a data scientist, what is the role of AI developer, where everything, let's say how everything comes together in a project. So there is a scenario for today called as scenario for a company called as it's basically a bank called as Woodgrove Bank, and they are looking for your help to drive the solution, and we will discuss that part. And we will also discuss we'll start from a very beginner level, then we will go to the intermediate level, and then we will also touch base on the advanced concepts as well. And apart from that, we will also be understanding from the architect's point of view. Like we will make some choices today, which will not be the popular choice, but will solve the customer problem as such, right? So I have the agenda with me, and I didn't wrote it in few points as such. I just made a diagram out of it. So this is the agenda for the day. We will be discussing about the streaming sources, how data is getting streamed, any function which we use for, you can say, catching the stream, writing the stream, what is the meaning of stream, what is Event Hub, Cosmos DB, Apache Kafka. These are various data ingestion solutions in Microsoft Azure. So how do we make it? How do you work with it? Any details around that is what we are interested in. Apart from that, we will also go into the preparation layer where we will talk about ETL, ELT, batch analytics, stream analytics. I'll show you practically. We will do some, you can say, deployments as such. And anything which I am doing, I will also provide you the links later on, so you can also replicate that. Now, even if you are getting started with Azure Cloud, or maybe you are looking for the certification of DP 203, DP 100, or you are an architect or anything in that particular field, then definitely this session will be very interesting for you. So we'll talk about Synapse, we'll talk about data lakes, we'll have Apache Spark also coming in, we will have machine learning also coming there, we will do some scoring with it. We will talk about Spark ML. We will have the serving layer as well. So how do you serve your data? We can use Kubernetes cluster. We can use ACI, container instances, Azure Cosmos database, Hive tables as such, SQL dedicated pools over there, which is basically OLAP. We'll see what that is, and Power BI. Power BI will be where we can create some good looking graphs as such, or you can say dashboards over there for this customer. So the very first thing is we will spend some next 5 to 10 minutes in the customer scenario. We want to understand the customer scenario. I will cover all the basics around these services. Even if you don't know about Synapse or any other service, don't worry, you will get it. But we will first understand the customer scenario. And based on the scenario, uh, we'll start, right? As such. Okay. So I'll just quickly turn off my video so you can focus on the screen. So today's scenario is about the bank Woodgrove, and they are looking for fraud analytics. And today the data is coming from various, you can say transactions are going on. The customers are paying the merchant, and the Woodgrove bank wants to do the fraud analytics over there in real time. Now, the frauds can be of many types. Even if you think it through, you will realize that we have ATM frauds, card frauds, basically card transaction frauds, payment frauds. So in today's session, we will be focusing on the online fraud, the any fraud where your card has been stolen, maybe, or maybe you're doing a transaction online and that transaction is fraudulent. And one of the scenario where fraudulent transactions are is basically somebody impersonated your account and did the transaction on your behalf, or basically impersonating you, or maybe by using some malware or some hijacking some cookies or internet sessions as such, or maybe they just you can say got your credentials and then they did some purchases on top of it. Now the Woodgrove Bank is so as per the case study scenario, the Woodgrove Bank is about to hit 10 billion in assets. So as per the US laws, the Woodgrove Bank will be now termed as a big bank. And whenever the banks are more critical for the economy, they are further, they have more strict regulatory fines on top of it if something goes wrong. So because of that, the Woodgrove Bank, whenever any fraud happens, whenever any financial crime happens, whenever there is any, you can say, funding, money laundering happens, funding for terrorist activity happens, or anything like that happens, or maybe other anyone sue the bank itself because of any fraud transaction, or maybe because where the bank was involved, then the big banks like Woodgrove are fined a lot by the government or by the institutes as such, and they at times they have to pay even a very big amount versus what was lost due to the fraud transaction. So now the Woodgrove Bank is they see the bank also understands that whenever we are doing the analysis, we can be very aggressive with the analysis. Like if you are suspicious about any transaction, you can block it. But what happens? There is a tug of war between what you block and what you let go. For example, let's say if by mistake or let's say by the machine learning model which we create, if the model blocks any genuine transaction, then that leads to frustration from both the merchant and from the end customer both at the same point in time. And typically what happens, the merchant or the client will not use this particular bank or the transaction processing system or that online system as such to do the transaction in future. So there is a loss of business. So the Woodgrove Bank want you guys to help them in creating a solution which works in two different speed as such. There is a fast moving speed which does real time fraud analytics. Now, if you do something very fast, as we understand that if you do something very fast, you cannot do it properly or accurately. So we can do a type of fraud analytics which is like a hot path. So I will show it to you how we are going to do that. So we are going to do some path analytics as such. And now, and then the rest of the frauds which will get processed due to the hot path analytics will be caught in the cold path analytics. So we have to think in terms of two different speeds. We will be doing real-time analytics and batch analytics. So using Azure platform itself. Now, and when we do this, we will be using a type of solution called as HTAP solution. So you might have heard about OLTP systems, right? Transactional processing systems, and you must have heard about OLAP systems also, analytical processing systems. The OLTP systems run the business. OLAP systems, they analyze the business. So HTAP system is a hybrid system which combines both the things together. So we will be using, this is the scenario of the customer. We are looking for fraud analytics. They have basically hot path, cold path analytics in real time. That's what we are focusing on today. And apart from that, they want to do machine learning, and we want to detect the frauds. There is another requirement of the customer is that this bank is global. So there will be multiple endpoints from where the data will be coming. So the data scientist and the data engineer has to get the data from multiple endpoints. Now, this is where we will be thinking about, can we use something like based on top of Kafka, or should we use something like a Cosmos DB, which can also help us in this scenario? So we will think it through in few minutes. We'll do a design session before we start deploying it, right? So okay, now the as part from the point of view of the customer, from the point of view of data scientist, we will be working with you can say years and years of transactional data. We have the data. This bank basically have historical data with them, and in the historical data, they both have they have labeled in our world, in the machine learning world, we call it labeled data. Basically, you have that the transaction was fraud or not fraud because it happens in the past. Somebody might have reported that particular transaction. So historical data will be there. And on top of it, we have to train the machine learning model. We have to train two different models, one for hot path, one for cold path. So we will see what's the logic behind that, but that's what we have to do, right? So the data is available in tabular format, and it will be available for you also and for me also in during the scenario as a CSV file where we can work with it. And the second part of the data is real-time streaming data, right? Data is streaming in real time, plus the data scientist has to train the model on historical data. So that's the scenario. Now, apart from this, we have to provide the fraud detection services. We already talked about it, right? And we have to make sure that we are uh, able to, we can say, get the store the data from the streaming source as well. Now, a lot of time what happens when you're working in a field where transactions are going on, it is mandatory by compliance that that particular company who's doing it, who is providing that payment gateway solution, should also store that raw data itself. We are not even talking about the process data in the warehouse or in the OLTP system or OLAP system. We are talking about the raw data itself, the stream itself, for some X amount of days. So in this scenario, this bank is supposed to store that data for 120 days, even the raw stream which is coming in. Now, so we have to think about the solution where that raw stream can also be stored. Now, we also will be, so this is where everything will come together. Data science, data engineering, and machine learning engineers or AI developers will also be part of the team which can solve this problem statement. Okay, so today I will, now in the next slide, I have the solution design with me. It's going to be pretty big. It's going to be a little overwhelming right now, but we will break it up. We'll go to the whiteboard, we'll go to the Azure portal, we'll start deploying it, and we'll think it one step by step. But I'll just show you the overview of the entire solution which we will be doing, which we'll be deploying today. Check this out. So basically, this is the preferred solution which we are thinking about, and we will cover these services. So we will be having Cosmos database as the ingestion layer solution, which will ingest the transactions. And the Cosmos database is a semi-structured database, which is globally distributed. So you can have multiple endpoints, which can be in various consistency levels, like strong consistency, or maybe a session-based consistency can be there. So the Cosmos DB is the ingestion layer solution. Now, the today's focus will be mostly on the Synapse as such, apart from Cosmos DB. So Synapse is the one where we will be doing the stream analytics, where the stream will be coming in, and where we will do the batch analytics. So this is where we focus more on. And the this Cosmos DB plus this Synapse Analytics will be deployed, configured, designed, and so on and so forth by the help of the data engineers as such. And the data scientists will be sitting somewhere over here with this Azure Machine Learning Studio, and over here they will be designing their ML models. So we will see how to do that. Now, when the model will be deployed, we have multiple ways to deploy it. We can deploy it in Kubernetes as well. We can deploy in Azure container instances as well. And other solutions are also there. You can deploy in a web app as well. You can put it there, or maybe in a VM as well. So now the scored these, but once the transaction is found to be suspicious, you have to have the output somewhere, right? You have to put the output somewhere. That location will going to be the Cosmos database. Why is it going to be Cosmos DB? Why are we not going for any other solution? All those type of questions we will see on the way. We'll understand it, right? But we'll put it in Cosmos DB, which will turn out to be the most suitable solution for us today. Now, apart from this, we will be putting the some historical data will also be kept in Cosmos DB. Now, if you remember, I was using the word HTAP, hybrid transactional and analytical processing system. These systems are something pretty useful in the cloud, and we will make one of them. And it's called as HTAP. Basically, Synapse plus Cosmos DB makes that. We'll come to it. And and the Power BI dashboard will be there. The dashboard I already designed because dashboard creation takes time. I'll just quickly show you the dashboard, and I'll show you how did I have made that. But this is the final dashboard where all the suspicious activities can be monitored as well. I'll practically walk you through how to make this dashboard and any thought process behind it, or what to think through it. Right. And now when the dashboard will be there, it has to read data from some location, right? So what is that some location? Is it going to be, what can Synapse provide us to create the dashboards on? What are those solutions? So this is the overall solution. Now what I'll do, I'll start from the Cosmos DB. I will start, you can say, breaking the solution up as such. We will go through to the data. We will understand the data as well. This is the overall look and feel of the solution, but where is the data? Uh, what are the rows, what are the columns? Data is not even cleaned, data is not in the right format. We have to do a lot of data processing today. Categorical columns are there. We have to do one hot encoding on top of it. We have to convert them, encode it, then train the ML models on top of it. So many steps are there. So we are starting from the left hand side from here where the data is getting streamed, right? And we will see what is the data, what are the various columns over there, and so on and so forth. So what I'll do, I'll just quickly open my whiteboard. I will start showing you here what we are doing, and then I'll explain the basics, intermediate and advanced concepts as well surrounding those topics. And then I'll show you the demo also on the way. Okay, check this out. So now the very first thing is, okay, I'll take a initial topic first. So check this out. So imagine these are the some apps are there from where the people are doing the transactions, right? The customers are selling, are buying something, and the merchant will be shipping the product later on, right? Now, whenever these transactions are generated, basically streams are there. Like these are in real time, some streams are coming in like this, like this. Now, if you have any you can say working understanding of Azure platform, or if you talk to anyone, whenever streams are coming in, we have the very first thing which comes to mind is Apache Kafka. Apache Kafka is a basically a pub sub model. It's a broker which is basically sitting in between the publisher and the subscriber. So the very first thing you can do in Azure is make a Kafka cluster. Now, Kafka cluster, we don't create in virtual machine. We create with a solution in Azure called as HD Insight. Now, it's not totally infrastructure as service. It's more like a managed service. But Kafka cluster is one of the thing which should come to mind whenever you can say any streams are coming in. It's a pretty popular solution in our world. And imagine the Kafka cluster will be looking something like this, and virtual machines will be there. We call them brokers. And in these virtual machines, we have a topic, we have a concept called as topic over here, right? Like this. So the data which is coming in, it is written in the partitions over there inside this. So imagine this is one partition, this is another partition, and so on and so forth. It can be a very big cluster also. So where do we make this cluster? The very first solution is Azure HD Insight. So HD Insight. So Kafka cluster goes in as inside Azure HD Insight. Now that's one of the offering, but that's not the focus of the day. Neither it depends. So I'll just give you some pointers over here. We go for HD Insight whenever you want some customization inside the Kafka cluster. You want to log in inside the head node and you want to install some custom, maybe you want to run a script over there, maybe you want to install some third party plugin, then you go for HD Insight. Otherwise, we have Event Hub in Azure, which is basically a service which is built on top of Kafka. So it's a PaaS solution. Like if I make this HD Insight cluster in Azure to ingest my streams which are coming in, then this will be, you can say, administratively pretty something to take care of, and it's going to be expensive and so on and so forth as well. So one of the preferred solution versus going for the Kafka in a VM is going for a platform as a service solution. It's called as Event Hub, right? Like this. Very popular solution, Azure Event Hub. Now, Azure Event Hub is built on top of Kafka. So the backend of Event Hub is Kafka, but it's a PaaS solution. So very, you can say, straightforward to work with, and very less, you can say, it takes less time to develop solutions with it, and it supports the same concepts. It has partitions inside that. It has the options to create topics. So you see, I'm trying to just show you that some partitions are there. Now, okay, so I'll just put some numbers also. It's really important for us to understand why we will be making some particular choice of technology today. If I work with Event Hub, basically one of the biggest Event Hub, I'm not talking about the smaller one. One of the biggest Event Hub is called as Premium SKU Event Hub. And that basically internally will have 10,000 brokers. So internally 10,000 virtual machine. It's brokered. It's broken over 10,000 virtual machines at the back end. You don't pay for the 10,000 virtual machine raw, like you don't pay for the RAM as such or any CPU as such, but it's pretty powerful. That's what I want to say. So at the behind the scenes, there are 10,000 VMs, but that's not what I want you to focus on. It supports 100 partitions. So you can see in the screen, I have this A partition, B partition, C and D. So whenever the data is coming in, data goes in this manner. And we generally put the data in round robin manner. So to equally, uh, you can say, utilize the partitions. So one of the biggest Event Hub will have 100 partitions over there, and it can retain data for 90 days, right? For 90 days, I can retain data. So if my backend goes down, if my subscribers goes down, so this is the publisher right now. See, so anything which is behind the Kafka cluster or Event Hub, uh, which goes down, then we can retain data for 90 days. But if you remember, the Woodgrove Bank wanted to keep the data for 120 days minimum, like that. And now 100 partition is a very big number. We are not denying that, but definitely 100 partition is a number as such. So in some scenarios, you may not be it may not be sufficient for us to go for 100 partitions. So definitely Event Hub was one of the you can say you can say contenders for the preferred ingestion layer solution, but not today. So for Woodgrove Bank, what we are doing, we are saying that okay, we are not going for Kafka cluster. We are not going for Event Hub because of two reasons. First, it is having those partition limits are there, 90 days retention limit is there. And apart from that, Event Hub is like single unit. And if you remember, the Woodgrove Bank is typically working globally. So if you have multiple Event Hub globally, then the problem is that these Event Hub will have different URLs. And from the developer's point of view, you have to configure those different URLs in the mobile application or in the web application. And then we have to think about a failover scenario if one of them goes down, and so on and so forth. It creates a lot of new problems which can be solved if we don't go for Kafka or if we don't go for Event Hub, but we go for Cosmos DB. So what is Cosmos DB? So today's preferred solution as for the ingestion layer solution is not going to be a Kafka based Event Hub, but it is going to be a Cosmos database where this is the structure of Cosmos database. Now, Cosmos database has a namespace concept. Namespace is on a global level as such. Like we will have globally one namespace, and that globally will have one URL, right? So the endpoint will be one. So it doesn't matter from where my customer is trying to connect. The URL remains same. It's the same endpoint to which the it will be connecting as such, uh, in a sense. Now, internally, what happens based on the least latency, the customer will be the application or the endpoint, or if you hit the URL, you will resolve to the nearest endpoint. So inside Cosmos DB namespace, we have endpoint concept. So you see these circles which I'm creating. So let's say this is East US endpoint. You know East US Azure region, right? So this is West US endpoint. Let's say this is Central US endpoint and so on and so forth. Maybe I should have made the central in middle, but you're getting my point. So these are the Cosmos DB and they are in constant sync with each other. So now typically what happens if I go for a Cosmos database as the ingestion layer solution, then I don't have that 100 partition problem statement. That doesn't come. Now the new thing which comes is, so what does Cosmos DB provides if in terms of partitions? So here you can create literally infinite partition from the customer's point of view. Microsoft says you cannot fill me up. Uh, create infinite partitions. No one is saying that you should create infinite partition because it will basically unoptimize your solution, but there is no limit on number of partitions which you can create as such. But the limit is there that in one of the partition you can keep 20 GB of data. So over here 20 GB data is there like this. So that's the per partition logical partition limit, which if you make the partitions properly will not get hit, or if you put a TTL on it, then the data can be moved also and data can be deleted also if not required, and so on and so forth. So, uh, so for this Woodgrove scenario, we are saying that versus Event Hub, let's go for Cosmos DB, which will not have the partition limit, which will not have the 90 days retention. You can put the TTL, it's up to you. Whatever you put will happen. If you put 120 days, it will keep the data for 120 days. If you keep it, you don't want the data to be removed, you can set the flag. It will never be removed as such. You can have any limit over there. And one of the good things is that it is having that single URL and multiple endpoints. So the customer always resolve to the endpoint where the latency is least. So let's say that this customer from East US will resolve in East US. And the best thing is Cosmos database is a semi-structured database, but still it provides strong consistency. It provides that. So if you know about any relational database, uh, it is going to be strong, consistent over there. So yes, so there is a question in the chat saying it is not a streaming solution, but how are we using it? Amazing, right? We'll see how are we using it. Okay, so first thing what I'm doing is I'm going to the Visual Studio and I'm starting. So you see this application which we have. So we have to do some transaction, then only can we do some real-time fraud analytics, right? That should make sense. If there is no stream coming in, then what we will analyze. So what I'm doing, I'm starting one stream. So what I have done, I have deployed one Cosmos DB in Azure. I'll show it to you in a minute. I have deployed the Cosmos DB and I have copied the endpoint of the Cosmos DB as such. This is the one. And I have copied the key of the Cosmos DB and I have put it here. And I'm just starting my transaction generator. So because we don't have any real uh, mobile apps, then the next thing is a transaction. So what it is doing, you will see it will start writing in a second or two. Uh, Okay, great. So it is inserted 999 documents over there. Basically, 999 transactions were inserted as such, and it will keep on doing it. It will keep on running for next 5-10 minutes. So we'll keep it running, right? Now, so what is going on? The data is getting streamed and it is getting inserted into Cosmos DB in real time. Right now, it's happening. So let's go to the Cosmos DB, have a look at it. Let's go and check it once. So this is my Azure portal. I'll just quickly, I forgot to just arrange it. 1 second. Okay, it makes my life easy if I have this search bar over here, navigation bar over here. And yeah, Cosmos DB. So this is my Cosmos DB. I have deployed it. If I'll just quickly show it to you. So when you create the Cosmos DB for the first time, right, you have these options. You can go for SQL APIs. You can go for Mongo API, Cassandra, Gremlin, and table APIs over there. Now the first two, this one and this one, if you make these two, then you will create a document database. Document database basically means it will going to store data in JSON format, right? So I will quickly show it to you. See over here. I have this page opened for you guys. You see this. This is the way the data will be stored. That's what we are using today. We have selected the SQL APIs over there. And this is how the data is getting inserted right now in document format. Now, what happens if I go for Cassandra? Then if you go for Cassandra, then it becomes a columnar database. Now it stores columns as rows over there. If you know what I mean, that's how it works. Like it works like Cassandra as such. Now, if I select the Azure table over here, then the Cosmos DB becomes a key value pair. So this is how the picture is of that in a sense like this. And what happens if I select the Gremlin API, then it becomes a graph database. This is how it looks like. It's going to store data in these graphs and relations will be there on the edges over there. You see this directed edges over here. So we have selected the Cosmos DB SQL API, and then there is just one more thing I just want to show you. I'm pretty sure you're already aware of it. That Cosmos DB is also available as serverless, right? So it's compute on demand. When you this is the PaaS one where you are provisioning, not really PaaS, but you are provisioning the resources. You are specifying I am going to give you uh, some X amount of resources. Now, just FYI, Cosmos DB works with a RU concept. We have request unit. So if you are doing 1 KB read in 1 second, that is called as 1 RU. So if you want to read 10,000 KB in 1 second, you have to give 10,000 RUs over there like this as such. And the writes are 5 times more expensive, right? Give or take, but minimum 5 times more expensive. So if I want to write one, uh, you can say, sorry, I should put it here on the other side. So if I want to write 1 KB in 1 second, it becomes 5 RU. We give that. That's the numbering, or that's the way we provision the resources. Now, the good thing is we don't have to worry much about it. Definitely, you have to do proper indexing, partitioning. You really have to do it. Otherwise, you will waste the resources. But in a sense, we can do auto scaling as well. We can simply say Cosmos DB, you auto scale, and whenever you need more, you go up and down based on that, right? So you can select those ways. I have deployed it. It takes 10 minutes to, it takes around 2 to 10 minutes. It depends on the region and the load as well in the region for the Cosmos DB deployment. So this is the Cosmos DB which I have, Woodgrove Cosmos DB, where my transaction generator is doing the transactions, is inserting that. Let me see, it got stuck or what? Oh, sorry, it is going on. Let it go on. Okay, so this is the normal look and feel. I'll go to Data Explorer. This is like a cloud-based SSMS type of concept. So here so Cosmos database is a semi-structured database. It doesn't have tables like relational databases. We have container concept here. So you see this one, check this one, the transaction one. This is where the data is getting streamed right now. And we have, okay, I'll show you that in 1 second. You see this transaction. I'll click on the items over here. So the rows in a relational databases now become items in a semi-structured database. Let's click on something. So this is one of the transaction. This is how the data is looking like. I'll show you the data way in a better manner also in 5-10 minutes, but just to have a look at it. Some transaction amount is there, transaction ID, when it was done, from which IP, let's say which state it was done, was there any proxy used, which language was used in the browser, and some verification of CVV was there, payment billing country code is there, and so on and so forth, right? This is how the data is getting inserted, and I have ran it 2-3 times since the morning, so it is having around uh, we can say somewhere less than 500,000 documents over there or items over there. I think as such, we'll see the count in few minutes, but I think somewhat in that number we have uh, the data is getting written over here now. So this Cosmos database is not even running in one part of the world. Right now, I have the East US and West US are the two regions which are both are multi-master. So in both the regions, we can do write. If I just select one more region, for example, if I find Central US over here, uh, let's say this one, I just have to say save over there. It will take some 5 minutes, but I will add one more Central US as the in a multi-master scenario. But globally, URL will remain same. So from the developer's point of view, they don't have to worry about failover. They don't have to worry about in which region they are writing. It will be strong, consistent, and it's going to be globally HA as well. Now, just FYI, Cosmos DB provides you with 99.999 high availability in the year as per SLA. It's one of the most HA solution of Azure over here. So this is what I'm just discarding it. I don't want it to save it for next. I don't want it to update it for next 5 minutes because my transaction will fail. I have EastUS and WestUS as multi-write right now. You can have multi-write as well, multi-master or single master multi-read scenario as well, right? It's up to you. Okay, I'll just click back over here and okay, so data is going in Cosmos DB as we are speaking. This is the database where the data is getting written. The transactions are being written over there. Now the second problem statement behind it. So why we are not going for event hub today? 100 partition limit. Secondly, 90 days retention limit over there. And in event hub, if you create event hub in East US, West US, Central US, and so on and so forth, then there is no centralization or there is no, you have to create a solution which can provide you strong consistency if required with failover if required. But Cosmos DB is providing all these things natively as per the design itself. So this is one of the reason by which these are the few reasons by which we are not going for Event Hub, but we are going with the Cosmos DB as the ingestion layer solution for this streaming solution, right? Okay, that's one thing. Okay, if you have any questions in this, put them in the chat window. I'll answer your questions. And I am just going to make some boxes here behind Cosmos DB going to the next part that how are we going to do the analysis on the data in real time as such, right? Fraud analytics over there. So I'll just make some few more boxes over here. Okay, I'll zoom into East, let's say one of them, West US, right? I'll zoom over there. Okay, I'll just zoom into East US. My solution is actually deployed in East US like this. So I'll zoom over here, right? I have a reason to zoom in over there. I want to show you something. Now in Cosmos DB, if I just go back over there, let me close the other tabs. So 1 second. Okay, let's keep that open. Okay, so you see this feature option over here. What I have done, I have clicked on this feature option. I have clicked on this Synapse Link option and I have enabled it. You see this on like that. It was generally by default it is off. I have enabled it. Why? What is that? What it does and so on and so forth. Now, as soon as you enable it and you enable the HTAP concept over there, what Cosmos DB does, Cosmos DB internally breaks into two pieces like that. That's the way I can put it. So imagine that Cosmos DB is breaking into two pieces. It has already done it for me, but just to put it here. Now, okay, let me see if I can make a straight line. No, not really. Okay, then we'll just continue with it. So you see this, there is going to be one OLTP part and there is going to be one OLAP part over here like this. Now, so the applications which are writing, they are writing in the OLTP part of the Cosmos DB like that. And we will be able to read from both the OLTP and from the OLAP part of the application for doing any analytics over there. Now, why is this done? What is the need and so on and so forth to do this? What is the concept behind this? Not typically, we have OLTP systems where which runs the business. Your transactional systems are OLTP systems like this, right? We have OLAP systems which are doing analysis on the data where we have warehouses, right? You will be creating reports on the OLAP systems and you will do many more things based on this historical analysis, descriptive analytics, describe why it went well or went bad or whatever. Now, the ETL job will be there. What is ETL? ETL job basically moves data from OLTP to OLAP. So the systems which are doing my business analysis and are running my business, data can be moved to systems where we are doing analysis on the data and we can do analysis on the data and find some ways to improve the data, to improve the business. Now, typically the delay, what is the delay over here? You see this, this is the delay over here, the ETL. So when your job will run, then the data will be moved. If you run the job every 2 hours, once a day, once a week, once a month, then only after that you can do analysis for your business. You can create some reports on top of it, right over here. Let's imagine some reports are there. So the thought, very genuine thought is there that you should think that why should we have two different systems? Why should OLTP be different from OLAP and then ETL should move the data around? ETL, if you know about Azure, ETL is data factory, ADF, right? Azure Data Factory or Azure Synapse Pipeline also. There is one more thing, right? So now why should we have this ETL do it as such? Can't we just merge both the systems together over here, right? Let's merge both the system and this becomes HTAP. So what is HTAP? Hybrid Transactional Analytical Processing System, meaning one system which is both OLTP and OLAP. This is what Microsoft did with Cosmos DB after I enabled the Synapse Link and I enabled the HTAP over there. It broke into two pieces. Not typically, or as a rule of thumb, or nearly always, what we do is the OLTP systems will be row oriented. So these are row oriented in a nature. The OLAP systems are column oriented, because in OLTP, what do I mean by that? Let me just put few minutes into it. So row oriented basically means that when the data will be stored at the data page level, like the smallest level, data will be stored like this. See, ABC, ABC, like this. Let's say some table was there, it was having ABC, ABC. So it is stored in this manner. This is row oriented way of storing data. What is column oriented way of storing data is basically you are storing the column as rows. So A's are stored together, imagine, right? All the A's are stored together, all the B's are stored together, some like this, and so on and so forth. Now, why do we do this? In the OLTP system, you have to retrieve one row or few row. That's the purpose of OLTP system. You have to, the customer will go click on the order history, will check out his past uh, 1 month of order over there. Maybe we'll check whether the order was successful or not. So what is that? You have to retrieve all the columns of one row. But in analysis, we don't do that. In analysis, you may be having, let's say, thousands of columns, and you will be requested to load 50 column, 100 column, and so on and so forth from those thousands of columns as fast as possible, and billions of rows at a point in time. So one column, but billions of rows. Or I can say a lot of columns, but billions of rows. So we store the data in a different manner. Just by storing this data in a different manner, it makes a huge difference, and you can load your data way, way, way faster. So in Cosmos DB, what happens when we enable the Cosmos DB HTAP, Hybrid Transactional Analytical Processing System? It breaks internally into two pieces. It starts storing data in OLTP manner in a row manner like this. So row format over here, and then there is an auto sync, right? There is no need to enable the auto sync. You can have other methods also, but there is an auto sync also. So I'll tell you about it, that auto sync is also there. So if you do the auto sync in you can say in somewhere 2 minutes, plus minus 2 minutes, it will be able to sync your data from the OLTP system to the OLAP system. The OLAP system will store the data in a different manner. So you are storing the data again, but it will store the data in a you can say columnar manner now. So the good thing is we have different request unit. RUs were the resources. You remember we just talked about them, like 1 KB per second is 1 RU, 1 KB per second write is 5 RUs, like that. So now you can have different RUs for both of them. So the OLTP system doesn't get affected when you start reading a lot of billions of rows from the OLAP system. It doesn't get affected. We can do it in this manner. Now, okay, so physically, I may not be able to show you in what the way I have created it. It just looks like this. This is all we have. That's all it looks like. But what we do is now I have enabled this feature called as Azure Synapse Link over here. Now what that does is basically I have also created one Synapse cluster. No, not sorry, not really cluster. Azure Synapse workspace over there. So what happens is at the back end, Microsoft you can say basically has a very high speed connection between the you can say servers where the Cosmos DB is deployed and the location where Synapse is there. I'll just tell you a few things about Synapse if that is a new word for you. But this is how it is this is how it's going to be looking like in a manner like this. So this is Azure Synapse over here. And then this is the Synapse Link, which is like a high speed connection at the backend. Now, what we will be doing, or what I will be going into and where we will spend our rest of the time will be, we will create some Spark clusters over there. Now, these are, okay, let's open a notepad first. Let's understand. So a lot of time people ask that what is Synapse? Is it like one product, one suite of product or whatever? Now, typically what happens, people compare Synapse with Databricks. They compare Synapse with data lake and all that. It's nothing in that sense, but I can explain that. So now the solution called as Azure Synapse Analytics is not a single solution. It's a suite of product over here, right? It contains four typically four things. You can add more things. You can say data studio and all that, but typically four things are there inside Synapse. I can create a serverless Spark pool. Serverless Spark pool is literally what it means, like Spark, but serverless. So I don't have to create the cluster. Cluster, I technically I have to create the cluster. I have to give the configuration of the cluster. Like what do I want? Like I want the cluster to be auto scaling. I want the cluster to be not auto scaling. I want it to be having 2 node, 3 node or whatever node. But the start, stop, everything is in a serverless manner. Like you just pay for when the job runs, and when the job doesn't runs, you don't pay for it. It just terminates. So it's very similar to in other cloud platforms we have query based solution, if you know what I mean. So it's very similar to that. So serverless Spark pool can be compared with Databricks, which is amazing, right? Like that. The second thing is we have dedicated SQL pool. This is basically a warehouse. So we store data there. This store data, right? It's a storage, relational storage, uh, and you run SQL queries on top of it, and so on and so forth. So it's a relational warehouse. Now, Synapse also has serverless SQL pool, with which we do EDA. EDA basically stands for the exploratory data analytics. Like I want to explore my data before I see, before you can transform your data, before you can clean your data, before you can do anything with the data, you have to see your data, you have to visualize your data, you have to understand your data. So do I have to make a Spark cluster to do it? Do I have to make how do I do it? Do I download it, open it up, and so on and so forth? What do I do? So basically that solution has been solved with this serverless SQL pool. I will show it to you in some time. The third thing is we can create ETL, ELT pipelines as such, which is equal to data factory. So in Azure, we have ADF over there. There is a question in the chat, what is RU? I'll just quickly put that. RU is request unit, right? So it's a unit in which we do the capacity planning for Cosmos database. It only is in Cosmos DB, right? Okay. Now, so Synapse is actually a suite of product. It has multiple typically four things inside it: serverless Spark pool, dedicated SQL pool, serverless SQL pool, and Synapse pipelines. Four things are there. So we cannot honestly compare it with Databricks because Databricks is just Databricks, right? So we can compare serverless Spark pool with Databricks, but not everything over there. So that's just one FYI. So this is my Synapse. So what I'm going to do is basically here we will be creating some Spark serverless Spark pools over there, right? So I have no other way of making it. I'll just make a dotted line over here, right? Maybe serverless, so dotted line over there. So this is my Spark cluster, Apache Spark cluster, but this is serverless. So serverless Spark pool. Now, see, if you want to do real-time analytics, right? Real-time analytics, meaning the person has done the transaction. Now you have to block or allow the transaction in real time. So how much time do you have? What do you think? Like you have maybe 2 second, 3 second, 5 second, 10 second, maybe something in that sense. You don't have 1 minute or 2 minutes. So what we do during the hot analytics, we read from the OLTP part. You see this? We read from here. So data will be read in this manner, the way my arrow shows over here. So this is what we will also do this. So the Spark, so we will have a job which is running over here, which will be reading the data from the OLTP part, and we will be using a thing called a Spark streaming. So Spark streaming basically means that the data is getting is getting streamed into the Cosmos DB, and we are reading the data from the Cosmos DB in real time into a data frame, and then we are doing something with it like this. So like this. So we will be finding the frauds over there, and when the frauds will be found, we will be we have another container in Cosmos DB. Let me just show this to you. You see this one. So notice this. Yeah, this one. Suspicious transactions over here, right? So if something is suspicious, if something has to be blocked, we are going to block that in the and we will you can say we will the outputs will go over there in the OLTP part. So I'll just make my arrows go properly. So this is how we will be blocking it. So any transaction to be blocked will be written in this manner. Now for the batch analytics, we so imagine the red one is doing hot analytics. It is doing in real time. Now you are running the batch job overnight, right? Or maybe once in a 7 days and so on and so forth. So what we do in this scenario, we read the data from the OLAP part over here. So every night or every 7 days and so on and so forth, you, whatever millions or billions of transactions are there, you load them on a very large scale, you run your job over there, and then whatever is getting blocked, then you tell the merchant that don't ship the product, the card was stolen or whatever, the transaction was fraud, so don't sell it. So but basically then same thing happens. We write in the OLTP part. Now why is it like this? Because read write happens from OLTP and this OLAP is only read only. So that's the reason we do it in this manner. And definitely you have to block the transaction, so you go back to the systems which are running your business, the OLTP part of it. So this is what we will be doing. I was going into the into this part. But just one more, maybe 5 more minutes, and I'll take your questions before I start with the code over there. Is that where how do you know the transaction is fraud or not, right? Whatever you see in the screen is more or less the job responsibility of a data engineer. They are supposed to do the configuration, they're supposed to do the integration, they're supposed to know how to run Spark, they're supposed to know the streaming concepts over there, the functions by which we read, the functions by which we write, and all those things are data engineers job profile as such. Now where is the data scientist over here? Where is the fraud analytics? Where is the machine learning and so on and so forth? So see, this data is coming in real time, right? There we don't know whether this transaction is fraud or not. Your solution has to find whether this transaction is fraud or not. You have to find it, right? So now what do we do? Historically, if you remember, the Woodgrove Bank had data. They had historical data. Last many years of data was there. So this is where data lake comes into picture. You see this data lake. Now I already have made it, but this is ADLS, Azure Data Lake Storage. Now just FYI, Data Lake is 100% compatible with HDFS. So the big data cluster doesn't understand that they are not reading from HDFS, they are reading from ADLS. So this is the storage location. Storage location, no upper limit, you can store any amount of data over there. And this is Data Lake over here. So the scenario is like this, that the, sorry, give me 1 second. Okay, sorry. So the scenario is in a manner that the Woodgrove Bank had I think around 10 years of data with them, historical data, and the data was not uh, it's not proper. We have to do many things with the data, but we have the data as such of last 10 years. So that 10 years of data is stored in this data lake right now in CSV files, and we will be working with 3 CSV files, and I will show you the columns now over there in next 5 minutes. So CSV files will be there. Now the data, and imagine this is a data scientist. This is where you come into picture. Today you are both, right? You will wear the shoes of both data engineer and data scientist at the same time and do everything. But that's the data scientist for you. Now what this guy will do, this person will basically create the Azure Machine Learning Studio or Azure Machine Learning Service, AML service over there, like this. So using this historical data over here, they will train the machine learning models, right? Like this. Now the models which are trained over there, Azure Machine Learning Service provides you the MLOps capabilities, right? MLOps. So you can integrate that with your DevOps, Azure DevOps portal itself. Now, there is a session which is coming on MLOps. Wait for it. Not so today we won't be integrating it, but we are going into that direction very soon. So now what we will do is we will get the data from the data lake, and then typically that data on that we will train the model. So we will train two different model. One data model will be there for real-time analytics. Now this real-time analytics model will be very fast. You can say inferencing will be done very fast, but it will not be that accurate, may not be that accurate. The number of processing on the data will also be not that much. So we will train two different models, right? One for real-time analytics, one for batch analytics. The batch analytics will take more time, but will be way better. Now after this we will register the models. Register the model means we will save them, sort of, in a sense, right? We register them in a registry over there. So there is a ACR is a ACR is a concept in Azure, which is basically a repository for images, image repo. So we save all the models over here in Azure ML Studio, but they save in the repository over here like this. Now, so what is going on is the notebooks which you are running over here, the data scientist made the model, saved it, Now the data engineer, when they will be doing any analytics, what they are doing is they are pulling that model. So this model is getting loaded from there. And how do they load it? They load the latest model. There is a versioning concept. If you register something, there should be a versioning concept, right? So they also have a versioning concept there. So versions will be there, model 1, 2, 3, 4, and so on and so forth. So they load the latest model based on the requirement for both the real-time analytics and the batch analytics like this. So the model get loaded and then it is locally getting doing the job over there or scoring as such. So whatever it says is suspicious is blocked. And then similarly, there is a life cycle because sooner or later more data will be there. So some delta data came and the data scientist will create another version of the model, maybe version 2 and so on and so forth. So this is the logic which we are doing. And this is my complete solution as such. And after this, I will just create some dashboard on top of it, but this is what I'm showing you today. The Cosmos DB HTAP, OLTP, OLAP, what are the various ways in which we can get the data into Synapse, any piece of code around that, how AML comes into picture. We have to go into it. We will see the little bit of machine learning also over there. And whatever you see in the diagram is what we are doing. And then based on this, we will be able to find the frauds in real time and in batch mode also for Woodgrove Bank. So if you have any questions, let me quickly go through the chat. Please ask your questions first. Okay, let me see. Request unit. If we store data in Cosmos DB, then why we store in data lake? Okay, I think you got your answer, right? Because that is a historical data. In Cosmos DB, we are storing real-time data, like whatever you do, whatever transactions you do today. But the data scientist has to find the patterns from the data, correct? The ML models have to find that. So you need historical data. So this is last 10 years of data over here. I think now you got your answer, right? This is 10 years of data. That is real-time data. Okay, so let's go to the Cosmos. Let's go to this Synapse now. Let's open that. Okay, let me close all this. Okay, just give me 1 second, guys. I'll just quickly 1 second. Okay, check this out. So let's go to Cosmos DB now. Oh, sorry, Synapse now. Okay, first thing, let's see the data. How do we do it? Now, what I have done is I have this data lake with me. I will just quickly go to the storage accounts and I think this one, maybe this is my data lake. I'll just quickly check container. Yeah, I think so. This is the one. So what I have done, I have uploaded these 3 files over there: account information, fraud transaction, and untagged transaction. In the account information of the customer is there. All the details about the customer accounts as such. In the fraud transaction, historical transactions are there where the fraud was detected. So this has all the frauds over there, all the frauds. Now this one is not having, so this is unlabeled, meaning it has both. See, so in the file, we don't know that is whether it is fraud or not, but it has all the transactions. Whatever has happened is there in the third one. So the very first thing is we have to also create our data. Data is not in the right format. What we have to do, we have to find the so from this file, so whatever transactions are in this file, we have to, with the transaction ID, we have to find those transactions in that file and basically say one. One means that that's a fraud transaction, 0, 1 today. So 0 is not fraud, 1 is fraud. So whatever is fraud, whatever is here has to be found there and marked as 1, labeled as 1, plus uh, plus whatever is left will be non-fraud. So then this will become our final data on which we will train the machine learning model. So right now that is unlabeled. Now, how do I visualize it? It's going to be a CSV file, pretty big as such, and so on and so forth. So what I did, this is how Synapse looks like. Like this is the UI of Synapse. Let's open another tab over here. Okay, so this is let me zoom out slightly. Too zoomed in for me. Okay. Yeah. Okay, so everything is on GitHub. I'll share the links to you with you today. You can also do the same deployment which I'm showing you. So just focus on the deployment right now. This is my Synapse. You just launch it from here. You see this one option will come in the middle of the page over here like this. You launch it and then this is the next page which opens up. Now it has everything on the left hand side. Now Synapse is like one stop shop for your data analysis requirement. It covers everything. It is not like just Spark or just like Power BI or some just one solution. It has everything inside it. So you can see data. We can develop solution. We can create pipelines to get the data from other locations. We can do monitoring. We can do some managing. You can say you want to get your data from on-premise. You want to have some link connection configuration to on-prem. That is over here in the last one. So I'll click on my data. Now what it does is whatever I have in my environment, which is connected with Synapse, will be showing over here in this format. See, so I have one Cosmos DB. I have a few data lakes, not one. So I have connected them. Once they are connected, they show over here. How do you connect them? You go to manage. You can click on the linked services over here, and you can click on the linked service over here, and then you search for it. It may be in your account, maybe somewhere else, but we can find it. So if you can see over here, and then you just search for data lake. Okay, Gen 1 is getting deprecated. You don't go for that. Gen 2 is the one which we use. This is the one, right? So I have already created these linked services which are visible over here. I have one linked service to data lake, one to storage account, one to Cosmos DB also, and one is by default. Like it's by default created. I didn't create that. So this is the one which I'm showing you over here, this one. So once you create the connection configuration to that particular solution, you can go to your Synapse Studio, click on data, uh, and then basically expand that and everything will be visible here. So what I showed you is now visible over here. So if I just click on it, this is my three, you can say data CSV files are there, three of them. So now if I right click on it, there are many ways to preview it. I can preview it in this manner. Okay. Doesn't look very proper because it's pretty small, but yeah, makes sense. At least I can have a look at my data as such over here. Right, see, like this. Second way is like I can just right click and I can say new SQL script. I can say select top 100 rows over there or create an external table. Now, if you are aware of Hive tables, this is that Hive table. So if I create this table, it will not have data. It will only have the schema. The data will be in data lake. It will just point to that data, right? Just like Hive external tables does. So that concept is this one. We don't need to do it right away as such. Okay. The second way is if I go to this options, then I can create using these. Okay, what is this? These options are basically, if I go back to my notepad, these options are provided by the EDA service, this serverless SQL pool. So I can run SQL queries on the raw data in the data lake by using the serverless SQL pool. So let's just right click on it. I didn't plan it, but just let's see. You see the data is getting loaded here. It's saying some by default. Let me push that back. So there's it's select 100 rows as such CSV format. The syntax is by default created for me, but this is my file path inside the data lake, and I will just run this. You see this built-in. This built-in means that I am using the serverless SQL pool, which is serverless but will let me run the SQL queries on my raw data inside the data lake uh, over there. So in few seconds, we will see the data getting loaded over there. In few more seconds, we'll see it getting loaded over there. Okay, so let it load over here. And it must, I'm not sure how many rows did I had originally. I had a lot of them. So let's wait for it. Okay. Okay, lot of rows. Okay, let it load. We'll come back in few minutes over here. We'll check it out how many were got loaded, but I already ran it for you. The data is over here. So what I have done, I have used the other functionality which is there, the Spark functionality. the serverless Spark pool to load the data to visualize it. How do you do that? You basically have to create this serverless pool over here. So if I click on this option over here, I think, okay, over here, these are some of the pools which I created. These are serverless in nature, meaning whenever you run the job, the job runs over there, then they terminate automatically. The first one is what we are using. The other two, actually, in my free account, I don't have the capacity, the quota limit to run all of them. You can do it in your production environment. You can run as many nodes you want, but we'll be using the first one as such. So we can use only one point in time in my free account right now, in my demo account right now. Okay, this is the one which I'm using, the Spark Pool one. So what I have done is I basically have loaded the data over there. And if I just make it slightly smaller, okay. So three files. This is the account information file. First, I have the fraud transaction file also. The second one, which has all the fraud transactions over there, right? And the third file is also there, which the third CSV file is where all the transactions are there. They are not flagged right now. So let's go through the data first. Now let's go to the account information. So account information basically has the account ID. One second. I have this opened with me uh, over here. Check this out. So this is where we have the description of the files in a way better manner. Okay, so let's find the account information, the second file. So this is the first one. Let's go to the second one. Okay, it starts from here. Like now, I have with me the transaction dates with me when the transaction was done, time of the transaction, who did it, the street address, postal code, age of the payment instrument, number of payments rejection in one day by this user. This is one of the major column for us. Which city, which state, which country, which date format, age of user, registered or not registered. This is my first, you can say, file over here, which we have loaded in a data frame in the Spark right now in Synapse. So account ID, transaction date, address, postal code. You can see some values are not available. We have to clean the data. Some values are here. True, false, and so on and so forth, right? The second file which we have is the fraud transaction, where all the fraud transactions are there. So which is described in this location. So unique transaction ID, account ID, the the transaction amount in currency expressed, the currency code of the transaction, date when the transaction was done, time of the transaction, in the hour as such, MAC address or hardware ID, and the full IP address from where the transaction was done. So these are all the frauds. Okay, the third file which we have is the one which is untagged. So this scenario actually will challenge the data engineers and data scientists to clean their own data. So data is not even in the proper format. Like what we have to do from the fraud, we have to find the fraud, do a join with the untagged transaction, and only keep the files which are, you can say, the files which are like the transactions which are common will be flagged as one, which are not common means they are not fraud, will be flagged as zero. That what we have to do in some time. So I have unique transaction IDs, transaction amount, currency code, conversion rate as such. The physical item purchased needs to be shipped, type of product purchase, shipping address, postal code, shipping city, uh, right? The CVV number, M if CVV number match, N if it doesn't match, P not processed, S some issue with the CVV data, U if the issuer is not certified, or issuer is not protected, is not provided visa with CVV to encryption key empty, and so on and so forth. Scenarios are there. Uh, then we have ID, payment ID, street address, billing, postal code, billing state, country code, IP address, which browser was used, and which card method was used. C will be there in the data for credit card, D for debit, PayPal, check, cash, others. Type of card, magnetic chip, and so on and so forth. PC, mobile device, console, MAC address, full IP address, state IP, uh, state of IP address, origin. So where the IP address came from, which state, full IP address, postal code of the IP address, all of it is relevant for us. in some, or you can say in various manners. Transaction type, purchase, refund, transfer, other, and method. How was it done? Internet, phone, mail, and XYZ. So these three files is what we are starting with, right? So I can visualize the files in Synapse by simply right clicking on the file and loading it in a using let's see if that query finished running or what happened with that query, right? So the query took 1 minute 17 second, but yeah, it loaded. Yeah, we missed the header. We can put the header as well, but this is the full data. Millions of rows are there in this right now, so it takes some time to load it, but that's the way it is. So now I have the data over here, but that was in SQL. This is in data frame in Spark. Now the next problem which I have is I have to basically start, you can say, visualizing my data. I need to understand my data first. So we have loaded the first file, the untagged transactions over there. The format is CSV, header is true, right? So the header is coming properly and transaction also got loaded as such. Now, this is where you explore your data. You should first know what is in the data, then you should decide a strategy to handle the data. Now, here, what I'm doing is I'm basically selecting the browser type. The browser type column is null. There is one column in this untagged transaction file, which is totally null. It's useless for us. What we will do with the entire column is null. So we are thinking of dropping it. So whatever is not useful for us, we are thinking of dropping it. This has no value, it's totally null as such. Now, apart from that, we will have two other columns: transaction scenario, transaction type. Both of them have single value. The transaction scenario is A, transaction type is P. Okay, let's see what is transaction scenario. Let's go back to that page I just showed you where all the data was there. And let's, okay. Transaction scenario means authorization, like you have authorization or not of to do it. Transaction type is having the value only P over there, right? As such. So purchase, like everybody did the purchase, nobody did refund or transfer. Okay, maybe makes sense. Maybe if it's a transaction, whatever. So in this data, everything is purchased as such, right? Maybe you cannot do fraud in refund or transfer. Not sure. Okay, so anyways, these columns are not really useful for us because they are having single values, and we will not be able to find any pattern into it because it's the same for everything. So there is no distinguish, there is no factor which is making a difference over there. Now, after this, we see that there is a particular column called as CVV verify result. It is having those MNPSUXV. This is what I showed you where the M meant that the CVV was present. You see this over here. CVV has matched, not matched, processed, some issues with the data and all that. So we have some distinct rows over there. Some null values are there. We have CVV matching, CVV not matching, some other problems, and so on and so forth. These are the value counts of that. Now, if we check out the schema of this particular transaction data frame right now, we have these columns are there, and you can say, and all of them are strings. Even the numerical columns are strings over there. So that is something which we have to take care of it. Everything is string right now. I'm reading this part over here. I don't see any other schema type right now. Everything is string as such. So I had visualized my data. This is something which we are doing in this box over here. In Synapse, we are doing that, not in really in that box, but we are visualizing our data, which is, you can say, from here over there uh, using PySpark like this. Now, once you have done the analysis of your data, now the next thing which we are thinking of is let's do the machine learning part over there, right? Let's do this ML. But before I go into that direction, I just want to show you this. You see this OLTP and OLAP, how do you read the files, right? This is very interesting. So if I just take you to my next file, which I have it created over here, my session has expired. So I have to start the session again. But I don't want to clear the outputs. I'll run this file for you, but I'll show the outputs first because it takes time, right? Everything generally sort of takes time. Okay, notice this. You see this OLTP. So if I write it like that, data frame spark dot read stream format cosmos but dot OLTP. This means that I am reading data from the red part over there, the OLTP part. But if I give it in this manner, uh, It's in, I think, one of my files. Give me a second. Let me find which one. Okay, we will come to that file in few minutes. In one of the file, this is not OLTP, it will be OLAP over there. It's in this batch analytics. I think it's over here. Let me see in which line am I loading the data, and scoring the transactions. Okay, I'll show you that part as well. But basically what happens is you see this OLTP. So this is what we thought that it's going to read from the row manner in real time where the transactions are going on. If I type OLAP over there, it's going to read from the other one, from the analytical one, which is storing the data in columnar manner. It's just one dot by which they have differentiated between this and that. Now, to be able to do this, you have to enable the Synapse link before. If you don't do that, nothing will work technically. So that Synapse link is already enabled, so it's going to work. Now we are going to Woodgrove Cosmos DB. That's the name of my linked service. Linked service is the connection configuration from Synapse to the Cosmos database. So I'm using that particular linked service name, the name of the connection string. So connection string is connection string, but you can give it a name as well, right? Technically. So that is what Woodgrove Cosmos DB is. Now I have this container call as transaction I showed you before. We are doing so change feed is basically we are reading. So whatever data is coming in, we are reading from the beginning over there. There is a checkpoint folder as well, and there is some query which is being named, and we are loading the data right now from the OLTP part into a data frame in Synapse. Once we do this, so if you let's run it, let's find it, let's run it. It has no outputs. Okay. So Spark pool, it's serverless. It will take some seconds for the pool to come up, and then it will run after it. The output of this line will be basically, is this data frame streaming data frame, or is it like a normal data frame, batch data frame? So this is a streaming. It will say true over there. Now, after that, there are some unnecessary columns which we values in the Cosmos DB which we don't need. It's not really unnecessary. If I just show it to you here, click on item, click on any one of them. But in today's scenario, we don't need them. But one of them, e tag, is pretty important for developers. If you see so this is my one document over here. If I just scroll down in this document, I have this the self, e tag, attachment, timestamp, all this. These are relevant information, but not for machine learning. This e tag is very relevant for finding the version of the document. Is it like if you know about pessimistic concurrency, sorry, optimistic concurrency, yeah. If you know about optimistic concurrency, then that is the most important thing for you, 34 line, right? But in the machine learning scenario, we don't need that. We really don't require it. So we are saying that these we don't want. So whatever we don't want, we are saying that don't select that. Whatever, every column apart from those column is what we are selecting. And then we can also, so we are loading data in a in-memory table, like it will be in RAM in the Spark cluster right now, and we just want to run the star count on transaction. It will be like somewhere around somewhere it should be less than 500,000. I have run this solution 2-3 times, so not sure what exact count will be, but we can come back and see in few minutes when the cluster will start. Okay, what is this going on? It's a Spark cluster, but serverless. It takes some seconds to start, and then the query executes over there. And once the query finishes, the file finishes, notebook finishes, it will deallocate or deprovision automatically. So the cluster got ready, and now my job will be running over there. So the session got started, and basically this finished. And let's just see the count over here. Then we will proceed to the next one. And we'll go into the ML part. So we are able to see the data over here. We have visualized it. Some columns are not correct. Some of them are, everything is string right now. We have to make sure that we have the proper schema. We don't want to take noise with us. All of that we have to do. So we will go to ML Studio. We will start doing the data cleaning, and we have to create the ML model over there. So count 0. Okay, 1 second. Let me run it again. So sometimes this happens. Okay, we'll give it some seconds. This is supposed to show me. Mm, or maybe I'm reading from a wrong Cosmos DB. 1 second, let me check that. Okay, the oh sorry, the queries is still running. I will just give it some time. The this one has not this write has not finished. This write has not finished. Let it run. We'll give it some time. Then we will run the last one over there. Okay. In the meantime, we have visualized data. Looks great. Let's go to the ML part. Let's go there. So in Azure, the main ML service is this service over here called as literally Azure Machine Learning Service. They have named it the way it is. So this one over here. Now, what this AML service does when you launch it, it looks something like this. This is how it looks like. That's the landing page. That's how it looks like. Now, this is the main service where we create custom machine learning models in Azure. You can do it in auto ML mode as well automatically. The data cleaning will be done automatically. Pre-processing will be done automatically. Deep learning can be done automatically for you. You can drag and drop and do it. Today is not that day where you can drag and drop and do it. So for this is a dense net, see, drag and drop, and it will be there in the screen over here somewhere like this. So not today, maybe right, but not today. So this is how we can do it. So or what else can we do? What I have done is, see, my data was basically in this data lake over here. Machine Learning Studio is not connected with that. So first thing which I did is I went to the Machine Learning Studio. I clicked on the data store, and I clicked on the new over here. I gave a name I gave is this one, Woodgrove Storage, and it's a block, and it's basically I have selected the this option over here, and I have selected the I only have one subscription, one data lake, and then the file over there like this option. Now, once I have done that, so the technical meaning of that is that we are connecting, we are specifying to the machine learning studio that that is where your data is. You can pick it up from there. Now, after that, what I have done is I went to the data set option over here. Okay, sorry, I did that in the notebook. So I went to the notebook and I created these two notebooks for you, real time and batch processing. We'll go through them now. But before this, from the data scientist point of view, like you have to run the models, right? You have to train the models, you have to develop your code and so on and so forth. So what we there is a concept in Azure machine learning service over here called as compute instances. So we have created one compute instance over there. This compute instance is basically it's your development environment. Compute instance is a development environment. So you don't have to have anything in your laptop. You can just access this compute instance over the browser and you can work with it. So that's what we are doing. And it is over in this tab over here. Compute instance, Woodgrove compute is running. It's basically a VM with some 4 or 8 GB RAM over there. We can click and find further, but it's some things are pre-installed over there. Jupyter Lab, Jupyter Notebook, VS Code, RStudio, Terminal as such. So we are using the Jupyter option, right? Now the notebook which is here, if I just do it like this, let's say I click on this option over here, basically editor and Jupyter, then the old Jupyter notebook opens, and this is pretty suitable for me as well. I like this over this UI, and it's up to you. Now basically what we are doing is we have to train. So our data is not in the right format. First thing, we have three files with us. It's not correct. We cannot create a target attribute. We don't have the feature labels right now. We have to do all of it. We have to train the ML model. We have to register it, and so on and so forth. Uh, Everything has to be done. The GitHub link, I'll put them in the chat window after this demo, right? I have it in the GitHub. I'll share it with you. So there is nothing which is in the right format. So the data scientist will log in over here, will start installing few libraries. I'll read it through the code, and we will go through the we'll go through this file very properly. We'll take our time in this file, and we'll check it out. So basically, if you notice, what I'm doing is First of all, I am just connecting to my data store. What is this data store? This data store is what I have connected over here, the same name which I gave in this line. So I am saying that read my data from data lake. That's the English meaning of that, like get the information about that data store from there. Now after this, we are creating one data set over there, not one, three data set. So this is account data set with the first file, fraud data set, untagged data set. Now, if just FYI, data set will be of two types, tabular and file data set. Tabular data set means something which you can load in a pandas data frame. File data set means that if you have multiple files with you, like you are doing some image analysis or you're doing some deep learning with you're creating a CNN model or something like that, and you have to read multiple files, then you create a file data set. You don't make a tabular then. So right now my data is a CSV file as such. So tabular is what we are doing. This is the name of the folder in data lake. If you remember, we saw that in the Synapse Studio a few minutes back. That's the other file, and this is the third file. So we are creating three data frames with those three files over there. Data set will not technically have any data. It's metadata, like file name, whether the header is there or not, recursive, non-recursive type of thing. It doesn't have data itself. It only has the metadata about the data. So at this point, the data got loaded. And we have seen this before. I don't want to waste your time, but this is the same fraud data set, which we saw before. This is the same account data set, which we saw before. Now, this is the third one, the untagged one over here, the one which is not in the right format, which we have to work with. So the very first thing is we have to prepare our data. Now, what we want to do is there are few columns which don't have the correct values or which we don't want to take further, like owner name, account owner name, account open date, account city, account address. These are not relevant, or at least in this scenario, in this point in time, they are not relevant for our scenario. So we are not taking them further. We are just selecting the columns which the other columns: account ID, transaction date, transaction time, postal code, state, country from where the transaction was done, age, register user is registered, which payment, how many. This is one of the most important column for us. How many payments were rejected by this person? If someone is doing a fraud transaction, they may have tried many times. So this is having that information. Now we do some, we just copy it up again. Uh, we uh, we just remove the NA values, NA non-NaN values as such, not a number. Any garbage value, some sort of corrupted values, and so on and so forth. All are we are filling. We are saying NA. These are NaNs, and then we will remove them. So we will clean our data. Now, once we have done that, this is the count of the various values inside the first in this column called as number of payment rejected by that user in that day. So in 5,500 user transaction, only one payment was rejected. In 1,476 transaction, two times the payment was rejected. And then so on and so forth. Whatever the counts are, the rejection is there multiple times as such. So what we understand is, okay, then what do we do? Let me go to the main parts over here. We are doing the data cleaning again. We have the R column is having some null values. We are replacing those values with negative 99. Then we will also remove them later on. But we are cleaning that column as well. R over here, local R. And then we have some more problems with the is proxy column, card type, CVV verification column as well. We are replacing some values over there. Anything which is not available, we are replacing them, imputing the values, and so on and so forth. And then finally, what do we do is we create labels here. This is one of the major part. So the target attribute which we have is what we are creating right now for machine learning. Target attribute basically means the column which your machine learning model will be uh, learning on or learning for, or you can say will be what it will be predicting that target attribute as such, or your dependent attribute. So this is we didn't had it. We didn't have that attribute. We are making it. So these zeros are not frauds and one will be fraudulent. So what we are doing is we are saying that in the okay in whatever transaction ID in the untagged data frame, which is in the fraud data frame, those we are going to say are fraud. Like we will make a column and we'll put 1 there. Whatever is left will be 0. So we will finally the data frame we'll have a data frame where the one column will be there where you will have 0 and 1. So this is basically like a join operation which we have done, but we have only taken the values which you can say make sense to us. Now after we have our data created, there is some sort of you can say uh, okay, so in this example, what we are doing is we are using a machine learning algorithm called as SVM. Now, SVM has every algorithm has some, you can say, recommended way of you can say treating the data. So we are doing normalization right now, and we are doing a thing called as uh, a z-score normalization on top of it, standard scalar as such on top of it. And that standard scalar will do a redistribution of data in a new scale called as z-scale. Now, these terms might be new to you, but just hang in with me. But if you know it, then you will be getting what I'm saying. So the z-scale will be there where the values will get normalized, and that's the way we want to take it. Now, apart from that, so this is where we do the standard scalar on the data. Now, if you notice one thing, you see this pipeline over here, like we are creating some pipeline and steps over there. Now, this is a very recommended method of working with AML service is that do it, uh, you don't do the individual data cleaning step manually. But what do? You make maybe a file, put the file in GitHub. Like I have a data cleaning .py, maybe a transformation.py, and so on and so forth, feature engineering.py, and then you make a pipeline, and in the pipeline you run those individual file on your data. It makes the code more modular. We can use heterogeneous compute solutions to run those particular files, and we can do the integration with Azure DevOps also. So MLOps comes into picture. So this pipeline concept is something which people have started using today. But being a data scientist, you can let me know if you're using it or not. But in the end of the day, this is a processed data where we have done multiple things over there. There is one thing which I should not have skipped, but I think I just ran through it. One hot encoding. We cannot do machine learning on categories because it's more or less mathematics, and you cannot run it on anything which is category like uh, maybe like red, blue, green, right? Like that category. So I cannot multiply that or anything with that. So we encode it. The next best thing is you encode it. So there is one encoding mechanism called as one hot encoding. It basically replaces that value with 0, 0, 0 and 0 ones as such. So wherever the value comes in the index, it replaces that with 0. So this is what it means. I'll just quickly show it to you here. So for example, if there is an index over here, let's say A, B, C, these are three categories as such, and this is 0, 1, 2. Then if I do one hot encoding, this is what will happen. Let's say 0, 1, 2, and A will be wherever in the row A was there. A will be like 1, 0, 0. B will be represented by 0, 1, 0. C will be represented by 0, 0, 1. So this new thing is called as one hot encoded representation of the categorical values. So definitely more columns will be created, but the libraries are pretty smart. They don't store the zeros, they store the ones. So mathematically, it doesn't make a big difference of running it on sparse metrics versus a dense metric, but this is what that one step is doing. And that is why you will be seeing a lot of 0 1s also in this table over here, 0 0 1 0 0 0, and so on and so forth. Other things are there. Now, after doing all of it, it's a one simple line. Yeah, so there is one more typical problem which you will face in the ML part as such is your data will be imbalanced. There are three strategies which you can go for when you have imbalance in the data set. Imbalance means that I have a lot of data points of one particular class and the other class is not that dominant. So in a fraud analytics, it always happens that the frauds are less, the transactions where frauds are done is always less versus where the transaction in which non-frauds are there. Like non-frauds are more in number versus fraud. And imagine it, just imagine it. If you have to give an examination and you just read one chapter and you forgot about the other chapter, or you didn't, you read let's say 14 chapters, and the 15 one you didn't read that much. So you literally don't know that. Like you are not trained for it. You don't have that capability to answer any question from that particular set or chapter or and so on and so forth. So whenever I have imbalance in the data set, see right now you see we have the triangles are less and the circles are more. Circle represent that non-fraud transaction, triangle represent fraud transaction. So whenever you have imbalance, you have three strategies. You can do oversampling, undersampling, you can do SMOT, synthetic minority oversampling. But so here we are doing the same thing. So what we are doing, we are creating a balanced data set. So in this step, we are doing it. And the balanced data set, once we have done it, it contains equal number of fraud and equal number of uh, you can say non-fraud. So the model which we will be training on the data which has both fraud and non-fraud transaction in equal number. So it will be a more balanced model versus a model which is more biased towards one of the you can say one of maybe the model knows how to find non-fraud but doesn't know how to find fraud over there. So that's what we are doing over here. And this is a typical data split. We are doing a 80-20 data split, and we are training the machine learning model on this particular line. We are training a model which is called as SVM, like that, and it's a classifier which we are training over there. And I just want to show you one thing that once I train this, I will also find. So this is a confusion matrix over here. If you are in the machine learning field or if you want to learn machine learning, the one of the initial day thing you will learn on day number 1 or 2 will be confusion metric. Like what it does is it basically has the this is what it does. So typically, basically, let's say this is the confusion metric over here. It's a box like this. Let's say 1010. Some classes, positive, negative, cancer, no, not cancer, healthy, not healthy, fraud, not fraud, all those things. So the model predictions are over here, and you can say the actuals in the data is over here. So for example, your model predicted 80 times it was fraud. Your model said fraud 80 times. It was not fraud. Your model said not fraud 10 times. It was actually not fraud, but your model said fraud 5 times and maybe 5 times misclassification. So my accuracy is 80 plus 10 divided by 100 like that. So that's what we are doing over there. It's a as such. Now this is not the it's I'm not saying that this is the only that accuracy and we don't have it pretty. It's not a very good model right now. We have to work on it, but it's a 0.64 is accuracy. So out of 100 transaction, it is only finding 64 transaction as such. This algorithm is not the best one. I'll put it the way it is. So that is accuracy. It's not very high, but it's sort of 0.6. Precision basically means that if something is of particular class, how many times your model got it correct. That is precision. Recall basically means that if your model is saying something, let's say it's fraud, then how many times it is correct. They are two different things. Like when something was fraud, how many times your model found it fraud was precision. When it was actually when your model said fraud, how many times was it fraud? That's recall as such. Then we have this area under the curve and we have F1 score as well. So what I want you to focus on is that this is the real-time scoring model, which is not having very high accuracy. But what we have done to work against that, we have also created another model with another algorithm called as ensemble models as such. Ensemble basically means that instead of having one model, see one model, if you are the only person giving the examination, then how many marks will you get? Whatever marks you get, but you may not be getting 100. But imagine 5 people sitting together giving the examination, right? Sort of you are sort of doing something over there. So now if many weak learners come together and they try to find the class, make the classifier, then it's ensemble model. So here we have that ensemble model and it is giving us 99% accuracy, pretty high. So these two are those boxes in my diagram. You see those 1 and 2, the real-time model and the batch model as such over there. Now what we have to do is we have to register these models so we can pull them later on. So that's what I do now. After this is I simply yeah, test it out, definitely test it out, but then register it over here. Now registry is very useful, very important. Without it, it will not work. Technically, these are the artifacts in your MLOps. In machine learning, the artifact is the model. Is that's one of the artifact. So we are registering it as a name called as fraud score in my machine learning workspace over there, right? Similarly, that's one thing. Similarly, I am also going to the batch one, and this is also getting registered over there. Oh, sorry, this is not getting registered. Mm, 1 second. I thought I did it. Yeah, this one. So we are registering the both the models. So if we go back to the machine learning studio, right, and we go to the model, you will see that it has many names. I run it many times, it seems. But technically, if you can see that we have three versions of the batch, and I think I only ran the fraud one once, so it's only having one version of the fraud model registered over there. So this model which is registered is the one which is made by the data scientist. Now that's the one which the data engineer will pull in the files over there while doing the stream analytics or batch analytics from the Cosmos DB using HTAP concept in Synapse over Synapse Link. So once the models are done, we will go back to our Synapse workspace now. So here we have these files with us, real-time scoring. Session has expired. Great, no issues. We'll start it again. Just a session. So we don't have the transaction generator must have stopped. So we'll go back and we will start it, because if there is no stream, then there is no real-time transactions, correct? So this is how will you find the frauds if you don't have the stream coming in? So my streaming is coming in now in a second or two. Okay, started. Great. So now let me do one thing. I don't want to stop the stream. So let me comment this out. Okay, let's run it. So those of you thinking it's not running, yeah, let's run it, right? So what this file will do is basically it will pull the model from my AML registry and will do the fraud analytics on the stream coming, which is going to the Cosmos DB. Run the notebook to start a new session. Okay, 1 second. I'll go to monitor. It means that some quota limit is hit because this is still running since the morning. Okay, let's cancel this. Okay, so I have this demo account with me, right? So it's not a production grade account, so it doesn't have it has quota limits. Like it doesn't go till hundreds of core. It has some limits over there. So I have to stop my previous session before I can start the next one. Uh, I should have actually raised the ticket to increase the quota, but I think I missed that or forgot it or whatever. So now it should start again. If there is no other session, then it should start any second now. Okay. In the meantime, it runs. I have started my stream. It is going. It is hitting the Cosmos DB. So in the diagram, this is going on. Like the data is going to Cosmos DB, and we have to do the analytics on top of it. So we are loading the machine learning model from AML, which we stored over there. The name of the model, we had two models over there. You can say batch was more accurate, and the previous one was less accurate. So what I'm doing, I am pulling the more accurate one because it is 99% accuracy. I just want to show a better demo, right? So it's 99% accurate. I'm not saying it might not be overfitting. I didn't focus on that, but definitely we're reading that model from there. Once we have that model from there, some more information about my account, some subscription IDs, and so on and so forth. So just some basic things. Now the model, we are deep. You can say we are getting the model from there. We are deep pickling the model as such, and we are opening the model. And then what do? We want to do a batch, yeah, real time and batch both scoring as such. So see, I when I did my model training, there was a particular encoding I did. There was a particular normalization I did. There was a particular cleaning of data which I did. I have to do the same thing on the real stream as well. If I don't do it, it will be like you taught your model physics and now you're asking some other language, chemistry, to the model, and it has no idea what's happening. So the same thing which we did over there, we have to do on the stream of data as well. So to do that, we are writing some functions over here. Some classes are there. We are doing the same cleaning over there. We will be removing some values. We'll be replacing some values. We will be taking the columns which we want, not all the columns. We will be doing the categorical cleaning on it, numerical cleaning on it, and so on and so forth. This same file will run in Databricks, so it is written over here. But you can run the same file in Synapse, which I'm running in front of you. So don't worry about that. But basically, okay, this is the main line. So we are doing a batch. We have created this function batch score over here. So what it does, it basically runs this score batch. What is this score batch? This score batch is where the machine learning is happening in this line, the model.predict. So the model which we have trained is doing the fraud analytics in real time. Whatever output we are getting, we are writing the output in a scored TF, like that, right scored results as such. And that right scored result is what we are writing back in the Cosmos DB in OLTP in the suspicious transaction container. So this particular line is that line which is going back from the red box back to the OLTP part over there, like this one, these suspicious transactions over here back to that. So this is happening on the real stream which is coming in. Second thing, can I do it in the, okay, notice this. Let me show that. Okay, let me show this one. So same model, same. I actually should have loaded the batch score here and the real time over here in the other file, but the batch one was 99% accurate and the other one was 60% accurate. So I thought that for the demo, let's do it with the batch one, which is way more accurate. So you guys will not say that it's a 60% accurate model. So it's not that good, right? So we did it with the batch mode, which is way more accurate. And you can further improve the accuracy of the other one. Now, this time what we are doing is we are basically reading from the OLAP part over there. And let's find that line. You see this one. So we are saying transaction spark.read cosmosdb.olap. OLAP means that we are reading from the other part, from this one, from here, right? And this job, whenever you run, you can schedule this job as well. You can run it with a pipeline as well, right? So this job may be running every day, once in a week, once in a month. Whenever it runs, it reads the data from there, from the transaction folder, and then it does the machine learning on top of it. So we are doing some pre-processing of data. Then we basically do the model.predict on top of it. And whatever output comes back, we write it back. So we find the suspicious transactions and we basically write it back. So which will be done in one of these steps somewhere. Okay, over here. So if you remember, I told you before that in Cosmos DB in this architecture, read write only happens from OLTP, read happens from OLAP. So I cannot write it back in OLAP anyways, right? I cannot do that. And the OLTP is the one where we are blocking the transactions. So in a batch mode, we are writing back in OLTP overnight in the same suspicious transaction container over there, blocking those transactions as such. Now, this is the main, you can say, main things which I had over here, where we have this OLTP plus OLAP HTAP with Synapse plus AML coming together. Now, I just have one last thing to show you, before, and I'll take your questions after that because we have around 10 minutes which are left. So apart from this, what I have done is I just installed uh, Power BI in this VM. And let me find the taskbar of that VM. It is not showing that properly. So yeah, I think now it should, or maybe like this if I do it. Yes, so this is the Power BI. I have, you can also install Power BI Desktop, which is free of cost. Or if you have the license of real Power BI, Power BI Pro, then you can also make a website out of it. So this is a desktop version, which is right now as such. So what I have done, I have connected this desktop version to my Synapse itself right now. And okay, Okay, so basically it's already connected over there. Now what it is doing is I have done this synapse and I have connected to this one. Next, whatever whatever server name you have, you go to your Azure resource group, find your SQL server name from there, copy it, give it here. Your database name will be Woodgrove or whatever name you give that name. It will open all the one thing which I have also done is I have created some views in Synapse, which I didn't cover, but I'll just quickly show it to you that I have it over here. You see these views. What is this? Pretty interesting concept. See, so what I have done is I have these views done on all the data which we have. On so in you remember Cosmos DB is where we had the suspicious, we had the original transaction, we had the customer information, and we had the suspicious transaction also there. So I have created some views on it directly on Cosmos DB, which is possible. So using the dedicated SQL pool, I made a view called as account. This one is pointing to the Cosmos DB metadata container where customer information is available. I created another uh, view on suspicious aggregate. It's another thing, another container in. It's basically suspicious transaction in Cosmos DB where we are writing the output in the previous step. There is another view create called as suspicious transactions, which is having some select statement and then it's created based on top of it. And it's also on the same suspicious transaction, but information has changed over there. And we have few more views over here. One more is there, transaction as such, and some specification of that. Now, this data, these views, this is what I have selected in the Power BI. These views over there. So whatever you see right now is coming. It's not stored anywhere. So honestly, the data is in Cosmos DB. Synapse is in the Synapse. We have done the EDA. So if I make it in my diagram, this is how it looks like. Like the data is in Cosmos DB here. So there is a view on top of that data in Synapse. Let's say this one. And on top of this one, I have made the Power BI dashboard over there on top of this. So uh, in a nutshell, I'm running my data. I'm running the dashboard on the OLTP data over there. Right. You can go for any other approach which comes to mind. You may say that Shivam, this will take some refresh cycles will be there. Why don't you write it somewhere, then read it from there? Anything which you say is possible, right? But this is what I have done. So I have these reports created on top of it. And these basically, what do they have? They have transaction amount versus the from which country more frauds were done, that information. From which country code suspicious activities were there, uh, in which are most frauds happened. In a map also, how can we see that? Percentage of the suspicious activity with the country code, from which country suspicious activity in which percentage happened. Pretty useful. So KW like that. Okay. So now suspicious activities versus the transaction amount. Uh, the which type of uh, you can say CVV verification result versus suspicious activity. Whether the user, which type of CVV verification was done. Like was it, uh, there were some few categories over there. So which type was it? Now, what is the overall, how many, this is basically a table type of thing. Like from which account ID, how many how many suspicious counts were done or non-suspicious counts. So you can see 18 somewhere 0 like that. Let me see if we have some values over here. Yeah, somewhere 682 is there total. Now, and then we also have this browser language, city, card type, and so on and so forth. Definitely, you can guys can make a way better dashboard than me. But this is just to show you that this has been created. And if I just click on refresh, it will load with whatever I have done today. So it's going to get my data from those views in real time and will update over there. So yeah, some rows are there. Okay, so basically it's going to refresh this page in few minutes when the query fetch me the data. And this is what I had for today's session for the demo, where we have created we have covered the Synapse plus HTAP, OLTP, OLAP, ML Studio, EDA, serverless Spark Pool, a little bit of data cleaning, a little bit of EDA, some technical things also over here. What is the sense of Kafka? When should we go for Event Hub? What is this Cosmos DB doing? Why did we go for it? Why did we not go for the other ones? We would have that would have been super difficult if you want to make that with Event Hub. You have to make that strong consistency, and that's going to be a very difficult. And Cosmos DB natively solves that. Then there is no point of reinventing the wheel, or in this scenario at least. So we uh, did this part. Now, please ask your questions. I will give you the links in the chat window, and we will be winding up in next few minutes. But please ask your questions first. I'll give you the GitHub link in the chat. Okay, I can see some questions are there. Let me see if I can read that. Is that a poly-based concept? Poly-based, I think, Venkat, you're talking about the external table. Yes, that is a poly-based concept. Can you share the Spark Streaming Notebook link later? It's in the chat right now. Everyone, please open that. That's the GitHub link. You can find the everything which I did is on that link. There are few folders. Go through it, and the files. Everything is available inside that folder. What are the scenarios, use cases we use Kafka or Event Hub if not supported HA like Cosmos DB? Okay. In any other scenario where data was coming from mobile devices, but this we didn't needed that partitioning was not the problem, or the you can say HA was not the problem, or retention was not the problem, then we would have gone for Event Hub. Event Hub is a PaaS solution. It makes life easy. So PaaS is more preferred over raw Kafka. You can go for Kafka if you have to do customization over there. Otherwise, may not go for it. So any other scenario, we may have gone for Event Hub for a normal event-driven scenario. So if any customer say event-driven scenario, most probably it will be you will end up with Event Hub over there. In this scenario, we didn't needed that. We went for Cosmos DB. Okay, so there is another question in the chat saying that if you enable another region, it will not be available for 5 minutes. Only that region will not be available, or only that region will not be available for 5 minutes. The new one, but my page would have been stuck. It would have. Uh, I didn't do it. I didn't do it because it would have taken around 2 to 5 minutes. You can definitely do it. Power BI to fetch data from Synapse, the Spark pool has to be up and running in the background. No, not really. We didn't read from the Spark pool. We read from the SQL pool, serverless SQL pool. So it didn't. The Spark pool doesn't need is not getting involved in what I did. The views were not created with that. Views were created with SQL serverless pool on the raw data. So Spark didn't came into picture in the last part. So no, it will not need Spark to be running there. Okay. Any other question, guys? Okay. Thank you, Krish. So next weekend we will have another session on. It will be basically machine learning, pure machine learning, and we'll bring in cognitive services and Databricks. Join me for the next session as well. I'm putting my profile, LinkedIn profile in the chat. In case you have any questions beyond the session, feel free to ask me over there. And you can uh, any thought, any question on anything. So right. Hopefully, you had a nice time. Amazing to get a good feedback. Thanks for it, everyone. And Rashmita or Vivek, if you are there, so we can wind up. Or if anyone has any question, then you can go on.
We'll just give it a minute, Shivam, if we have any last question, or else then we can just wrap up the session.
Sure.
In the meantime, please feel free to do event check-in and share your feedback about today's session. I've just shared all the links in the chat section. So I think we are good, Shivam. So thank you so much for hosting the session, and thank you all for joining us today. Like I said, please feel free to do event check-in and share your feedback about today's session. Also, please visit our Microsoft Reactor Bengaluru meetup page for more upcoming session. Thank you and have a happy weekend, all of you.